Hi, this is Beverly Owens Lab Section M03 with At Home Lab 11, modeling a rope swing. The problem we are addressing is understanding and predicting the motion, velocity, and forces acting on the rope swing. The main result from analyzing our swing and mass system is that the predicted position closely aligns with the measured position, varying slightly in the Y direction due to the video slightly being in the Z direction in reality. The velocity of the swing is calculated using Newton's second law and the momentum principle. The determined velocities are the initial velocity of 0 meters per second, halfway through the descent being about 21 meters per second, and the bottom of the descent being 26.8 meters per second when the experiment is modeling half a swing. In Tracker, the length of the rope swing is set to 45.72 meters, which is the given length of the rope. The positive x direction pointing slightly down to the right to model the imperfect pendulum swing due to the experimental models being slightly in the z direction. The person on the end of the rope swing was plotted during 3 seconds with a frame rate of 30 frames per second. The initial conditions were set in VPython, the person's mass being about 63 kilograms, the initial position at the top of the swing at negative 43.9 in the x direction, negative 1.9 in the y direction, and 0 in the z direction for meters, and a velocity of 0 because there was no speed at the top of the pendulum. Because the force of gravity was not the only force acting on the system, variables had to be defined to solve for the spring force. The angular frequency was first found by dividing 2 pi by t, which was about 6 seconds in this case because I was only modeling half an oscillation. The angular frequency was then used to solve for the spring constant of 69.45, and the length of the unstretched rope was given at 45.72 meters. The spring force was then calculated by multiplying the spring constant, stretch, and negative L hat. Newton's second law and the momentum principle were then used to calculate the velocity of the person as they swung on the rope. This was done by multiplying the net force by delta t and dividing this by the weight of the person. This was also used to find the position to verify that the code correctly modeled the rope swing. The position was found by adding the initial position to the person's velocity multiplied by delta t. The position was slightly off in the model in the y direction due to the approximations made that the pendulum was only acting in the x and y directions, where in reality, the pendulum was also acting in the z direction. Due to the tracker system not able to measure in the z direction, calculations were slightly off, but not enough to be able to see a similar model comparison. The model was used to determine how fast the person was going on the rope swing at different instances. The initial speed was 0 for a brief instant before descending back down. During the halfway mark between the top of the swing and the bottom of the swing, the person was rapidly increasing their speed, swinging at 22.3 meters per second, and when they reached the bottom of the swing, they were swinging at 26.8 meters per second. To find the changing velocities, the ending time was changed according to where the velocity needed to be found, and the magnitude of the velocity was calculated. The way the velocities change gives the idea that the person went back up to the top of their swing to finish the swing, that the speed would decrease. When the model is run, the forces acting on the system are seen from the arrows. The net force shown in green, the force of gravity in red, and the spring force modeled in blue. The spring force constantly points up in the direction of the rope and increases as size as the swing reaches the lower portion of the swing. This causes speed to increase because the person's weight is aligned with the rope and gravity, causing the rope to stretch more. When the code is run at the final time of 2.9 seconds, the output position of 4.27 in the x direction, negative 68.9 in the y direction, and 0 meters in the z direction closely compares to the experimental swing at 4.29 in the x direction and negative 45.23 meters in the y direction, verifying that this model makes correct assumptions from the rope swing analyzed.